Hello, and welcome to Lesson 28 of this Introduction to Calculus with Wolfram U. The topic for this lesson is areas between curves. So let's begin with a brief overview of the topic. So when you calculate integral, you're really finding the area between the curve of a function and the x-axis. So for example, here's a function, and when you compute the integral for that function, then what you're really doing is to find the area under the curve. So in this case, it's the area between -1 and 1, which are the limits for the integral over here. So the question is, what would happen if you want to find the area between two curves? So this lesson will go over several examples of how you can do this using integrate. Okay, so let's take an example. So let's say f of x is 5 and g of x is -x squared plus 1. Now clear in this case, the function f is greater than the function g because that's positive and that's going to be negative for most of the time, but it won't go over 1. So now when you want to work out the area between them, what you do is look at the Riemann sums. Now in this case, the Riemann sums will have the height equal to f minus g for each strip, and the width will be b minus a over n, where b and a are the limits of the integration interval. And so now the Riemann sum will be the sum of the heights times the widths, which is the same as the integral of f minus g. So basically, if you want to find the area between the preceding curves, then all you do is you work out the integral of f minus g and you get back the answer 76 over 3 in this case. Okay, now two questions. First question, what would happen if we didn't know the limits of integration? And secondly, what would happen if you had to actually work out which function greater or less? But before that, let's take a simple example. So here are two functions, and you want to work out the area between them with x equal to 1 on the left and x equal to 5 on the right. So in this case, everything is given to you, so we can work out the integral of f minus g and get the answer 88. So here is a plot of the area which you just computed. So now back to the question which I asked early on. So first question, what happens if you're not given any endpoints? So let's say you've got two functions, f and g, and you want to find the area enclosed between the curves given by these functions. So what you do then is you work out the points of intersection using solve. So the curves intersect at negative square root of 3 and positive square root of 3. So here is the plot of the curves between those limits. And you can see clearly that f is above g in all cases. So you can work out the integral of f minus g and you get the answer for the area enclosed between these curves. On the other hand, suppose you have the functions sine x and cosine x, then you can see that the functions f and g are either above or below each other depending upon where you are. So let's say you want to find the area between -3 pi over 4 and 5 pi over 4. That's roughly starting over here and ending over there. So initially, the cosine function is greater than sine function, and then the sine function is greater than cosine for the rest of the interval. So on the first interval, -3 pi over 4 to pi over 4, you have g minus f because g is greater than f, and then you do the opposite for the rest of the interval. Then you add the two answers and you get back 4 times square root of 2. So the point is that you will now need to divide the integration into two parts depending upon the behavior of f and g. So instead of doing that, what we do is we just call integrate with the absolute value function, which will take care of all the difficulties, and you get back just the same answer from integrate. So given two functions, f and g, if you do not know which one is greater or less, then you use the absolute value function to find the area. Okay, so let's now talk about cases where you've got a function of y. So x is given as a function of y in these two functions, f and g. So to find the area in this case, you now need y limits. So again, you work with Riemann sums, but now you have the Riemann sums with widths given by delta y. And instead of talking about above and below, we talk about rightmost and leftmost functions. So in this case, if you plot the functions, it is clear that the function g is to the right of function f, so the area will be given by the integral of g minus f between minus 5 and 5. Okay, now an example where you might actually need this is, let's say given y equal to 3x plus 1 and the parabola y square equal to x plus 4. Now in this case, y is not a function of x, so we try and write x as a function of y by solving. Set up two functions from the first solution over here and the second solution over there. Then you find where they intersect, do a parametric plot, and it's clear that you actually have the function f to the right of g, so you do integrate of f minus g between the limits negative square root 1 minus square root of 33 over 6, etc., and you get back the answer for the area between those two curves. So you can either work with x limits or y limits, they both work just fine. So it's now time to summarize the lesson. So basically, finding the area between curves is really easy once you have integrals. And in case the function f is greater than function g, you simply do the integral of f minus g. Now when you don't have that information, then what you do is you figure out where the functions intersect using solve, figure out which function is above and which one is below, and then you find the integral by doing the integral of f minus g or g minus f, or simply using the absolute value function. Of course, if you're given functions of y, then you work with y integrals. So let's say you might do the integral of f minus g in case you know that f is to the right of g. So that brings me to the end of this lesson, and in the next lesson we talk about volumes of solids. But before that, do review this topic of area between curves. It's a very important and useful part of calculus. So I'll stop over here. Thank you very much.